Hey everybody, this is Larry. This is day 23rd of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about today's farm, gas station. I'm sitting here like dressed up like a Sith Lord because it is very chilly here in New York. But okay, gas station, the end gas station along a circular well. You could see if you could probably just get through all of them. Okay. So I guess the naive solution is n squared. You just try at each place and then go through one loop which takes off. And I assume you need to do better, even though they don't tell you the constraints, because otherwise that's like a for loop or two. I think you just I think for me this problem is just greedy. On whether there is a way to solve it. We could try it all at the same time, meaning by greedy, because if at any time you get to a location and it is negative, then you cannot start there anyway. Right? Maybe? I would say greedy solutions are always a little tricky, so I think that's where my intuition is. And if you do a loop twice, that should be sufficient, because it essentially means that you're trying the entire starting everything at the same time. So basically, in general, there are basically two conditions that I'm trying to think of. For example, for gas and cost, right? The only cost is more than gas. In this case, you get a negative, obviously. And then the other one is gas is more than cost, so that's positive. And then the only other third case is if there's zero, they match, so it's zero. I don't know if you need more, or being even is okay. But because of that, it's almost similar to that I forget. I'm forgetting the name, where you find the max subarray in a thing. Because at any time you reach zero, you go, okay, that means that the prefix of it cannot solve it, so you start anew, right? And I think the only thing that I think about is whether, yeah, and I think that should be okay. The only concern I have was, like, let's say you have, I don't know, let's say you start with, 10, 1, and then you have like a big negative. What happens, right? Well, in that case, you need to do that anyway. So I think that greedy probably works, because we have to hit each spot at least once. Yeah, okay. Let's play around with that. It's very similar to what was that? Get maximum sequence in a subarray. Except for that this one is circular, larger sums with Cadane's algorithm. So that's where my mind is going with Cadane's algorithm, except for that, you have to do the delta on them, right? Cool. So let's kind of play around with that, and because it's circular, I just multiply by 2, because then every station, if you will, has a chance to become the first element. And it's only unique, which I guess that makes it easier. So yeah, so now I just do gas is equal to dash time 2. I think that's okay. Sometimes I get a little bit, the Python syntax is a little bit too magical for me, but okay, so it looks like that's okay. That is what I intended. And then now let's just do current length, and if you read up Cadane's algorithm, it's going to look very similar. But I would also say that Cadane's algorithm is a dynamic programming solution. So even though usually people don't write it that way or think about it that way, so even though in a way, I know that I've said this is greedy, but it's also dynamic programming, because for every point you ask yourself, do you start at that point? And then you kind of look forward as a result. Okay, so current length is equal to 0, say max length is also equal to 0. And then for GC in zip of gas cost, I was just trying to figure out what to name these things. Okay, what's the current gas is equal to 0. Okay, so current gas is plus minus cost if current gas is greater or less than 0, and I think you could get there just in time for 0, so that's why I'm double checking whether I need this to be less than or equal to. If it's less than 0, then we just do gas is equal to 0, current length is equal to 0. Yeah, and then max length is equal to max of max. Oops, can't type today. Current length, and that may be it. And then we just have to return. Oh, I was gonna say that we just because I thought it was Boolean for some reason, but that's annoying. That we have to. I mean, it's not that annoying. I just have to keep track of one more thing, which is the index. And then that's it. Stored index is equal to none. If this is thing, then yeah, stored index is equal to none. And then okay, we could just do else if current gas is equal to 0, then stored index should equal to 0. But then this may have an edge case, so that's why I'm hesitating a little bit. I think maybe I skip ahead a little bit because, as I was saying, if this is dynamic programming, then it's and you draw the array, it should be easier to figure out just by any number of ways. But yeah, I mean, I think actually we don't need this. This is too fancy. We can just do if max length is greater than current length. Well, max length, or the other way around, is equal to current length, and start index is equal to the current index minus max length. Right? And then now we just return the start index. If it's guaranteed that it is good. Okay, if it's not, then we return -1, so we have to check that, which is if max length is less than the length of gas, and we have to fix this because we multiply by 2. So let's just multiply 2 on this side. Return -1. So that should be okay. Let's put this in as well. Ooh, did I have a typo clearly? Oops. Now I know. Oh, right. I knew that I needed to do this while I was typing, but I just forgot. Sometimes a little bit lippy. Okay, cool. So we're halfway, so that's good. But I didn't expect this to be wrong. So 4-1, that makes sense. So okay, maybe I'm off by 1 somewhere. So let's kind of take a look at the max length. And oh, we don't increment current length. I'm just being silly. Yeah. So maybe that's enough. I was thinking about that as I was doing, but I don't know. Now I just have to double check whether it's off by 1 or I'm just being because I did the starting index, so I rushed it a little bit. So I didn't really think. So if this is 2, if this is the index, then the max length should be inclusive of this index. So this should be +1, I think. But now I'm not so certain. So let's. Well, they say that the answer has to be unique, otherwise. So it's hard to kind of just come up with an answer, but we can actually just try the same answer, but maybe off shift by 1. So, and then hopefully that's okay. At the very least. Okay, I mean, let's give it a submit, and maybe we'll see where that goes. Okay, cool. Yeah. So this actually looks exactly, now that I look at, I mean, I wasn't sure when I was coding it, but now that, I look at the code and that it is correct, this is exactly Cadane's algorithm. And depending on which problem you're asking, you might have to keep track of the start index or something like that. But But yeah, this otherwise is a as I said, the I think what I would go over is the max sub-array sum. I think that's the problem that contains algorithm is familiar with, and try to understand the dynamic problem solution to that one. And that's kind of actually the way that I formulated in my head a little bit. I was like, okay, it's a dynamic programming solution that let me go through. But then, like as I was seeing, I was like, wait, this feels a little greedy. But with an understanding of contains algorithm, you should be able to kind of do every possible point at the same time, and yeah, and because this is just asked you in a very Boolean kind of way, yeah, it doesn't even have to be that. But the idea is that, as I was talking about earlier, that if you have positive, you always want to take the positive, and even if there's a negative afterwards, you're gonna, in this case anyway, you have to go for a full loop anyway. So yeah, and I think there's actually a Leetcode problem on the circular max contiguous array as well. So definitely play around with that, or circular array maybe. But yeah, so what is the complexity? We could go over it really quick, but hopefully you are ahead of me and don't need me to tell you. But this is O of n because we only look at each character once, and this is O of okay, so the way that I did is O of n space, just because I am lazy and I wanted to optimize for correctness in a competitive kind of way in my mind. But definitely, if you now that because for me, especially for problems that I'm not 100% sure about, the first thing I would do is optimize for correctness, and then once I got the complexity right, I'm going to I'm going to focus on the space, right? Or optimizing the problem. And for this one, you can easily see that you can actually just you can actually do this all in one space. Even though the way that I did it is all of n space, and the way to do that is just you're given an index, you just, instead of going from 0 to n, you go from 0 to 2n, and then this index you just look up mod n, right? So that's a very simple way to convert it to all one space, but I did not do that, but that's okay. But yeah, that's all I have for this problem. Linear time, my solution is linear space with a very easy optimization to all one space. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and wish me good luck on my neck. I think I got a neck sprain, so it's been a little bit rough, so I always have to rotate this way. Anyway, I will see y'all tomorrow. Bye bye.